So a little bit about me. I'm a physicist, a theoretical physicist, and one of the things I like to think a lot about is dark matter. And I like to write down theories of what it could be, and also think about, for instance, the xenon detector that we met briefly, how we could potentially look at their data a little bit differently to discover dark matter, or at least constrain new models of dark matter that we hadn't considered previously.
Great. All right, Steve, so you have your choice of subjects are so diverse, so I want to know about what set you on this journey. Why did you pick Chasing Einstein and to follow these scientists?
And is this working here on this thing?
Will help
okay,
also for
okay,
the audience.
okay. So since the beginning of time, for thousands of years, we've looked at the heavens to look out there to sort of ask the questions about, like, who are we and where did it all come from and what does it all mean? And for the last 400 years, we've been looking out there more closely with more and more advanced technology, from the first telescopes that Galileo used to now the greatest instruments that have ever been built by humans, which, these greatest telescopes, these greatest detectors, they're all different ways of looking even more closely out at the cosmos. And so what we were looking for is, like, where is that frontier today of science? And it's where we're looking closer than we've ever looked before, with more powerful instruments than we've ever looked before. And where are we seeing things that we didn't expect, or not seeing things that we did expect? That's where you'll find the frontier. So the premise of the film really was to ask that question of, where is that frontier today? And are there people on that frontier today, just like 400 years ago when Galileo looked with the first telescope and saw things that were different than the prevailing wisdom, and either kind of have had a choice back then? Is there a whole new way of looking at it, or are there some things to plug into our old model to keep making it work? Einstein, for the last 100 years, the prevailing theory of gravity, was also the result of looking more closely and seeing anomalies from Newton that came before Einstein, and then saying, well, maybe there's some missing planet, or maybe there's something missing out there that we didn't find yet, or maybe there's a whole new way of looking at it. And so that's when these paradigm shifts happen. And today we're at a time where Einstein is still the prevailing theory of gravity, but we now have to say, well, 80% of the matter out there is something we haven't found yet, or 96% of everything is out there that's something that we can't even measure or detect it with dark matter and dark energy. So that sort of feels like, it's been 100 years since the last big paradigm shift. Maybe we're due for another one, and what would that mean? What would it look like to be on the frontier? So that was the question of the film. Everybody in the film that we picked them because they were people on the frontier with the most significant, most sensitive, kind of greatest instruments that have ever been created by humankind on Earth. So we kind of went there and we said, who in those places is kind of at this kind of dilemma on the frontier today?
Nice. What I did love about the film also, even as much of the science is there, you were able to capture each of these people's personalities, their idiosyncrasies, their quirkiness. You gave them this wonderful human qualities, and I just wanted to say that I thought that was really well done, and it seemed like you also captured the disappointment. You obviously didn't know when you started what the outcome would be, because the scientist at Columbia hadn't opened her box yet. So can you share a little bit about their personalities and what you discovered along the way?
Scientists are people too. I think that when you look at science in the media, the only thing that gets press is sort of the huge, significant, celebrated discovery, which is, you know, 1 in a million. What you don't see is that all of the learning experiences and all the things that didn't work out, the real process of science is all the stuff in between. And so that's another thing that we wanted to really show, because we've already seen in the news the big celebrated discovery, but very few people see the ups and downs and the challenges of the actual process of science.
And the dedication. So, Robert, when she didn't find the black matter, the dark matter, why do they not give up? I mean, it seems like you have one scientist who's saying it's not there, and then you have everybody else over here saying it is there. What keeps them going? What keeps you going?
Yeah, so I guess I can't speak for them personally on the xenon experiment. Certainly they were very disappointed, and I felt sad with them, being a fellow physicist and someone that thinks about dark matter a lot. It certainly would have been very exciting. I was kind of crossing my fingers. I know they didn't find it, but just watching it here, I'm like, okay, maybe in the movie they find something. But so one thing that keeps us going is, first of all the evidence that something's there. There's certainly a lot of evidence for something being there. Now, whether it's a particle like a lot of people might think, or it's a bigger paradigm shifting thing, we're not sure. But certainly there's evidence that needs, there's data even that needs explaining. And so that certainly motivates myself in trying to come up with clever new ideas for what dark matter could be. Maybe not paradigm shifting, but at least different in a way that we're just around the corner from finding it. And I think another thing that would keep me from giving up entirely when they didn't find it at Xenon is just to consider really how little we know about this stuff. So one perspective I can spin on it is the following. So we know so little about this dark matter. If it actually is a particle, then it could be anywhere from 31 times 10 to the 31 times lighter than a proton. So that's 10 followed by 31 zeros, lighter than a single proton. It could be all the way down there consistently. If you go lighter, you have problems, but you could be that light. Or, yeah, believe it or not, there are actually problems. But anyways, you can go all the way down to 10 to the 31 times lighter than a proton, or you could go all the way up to as high as you like solar mass black holes or even higher. And so that's an enormous amount of place to look. And the xenon detector is built specifically to look for a particular type of dark matter called WIMPs, which I think they maybe mentioned very briefly. And that dark matter lives in a very particular spot around a proton mass up to maybe 100 times heavier than a proton. And outside of that window, in this huge possible spectrum of where dark matter could live, they would never have any possibility of seeing it. So it's definitely disappointing, but at the same time, it makes me try to think about where else dark matter could live and also how we could try to find it there.
But it's a really big universe, and the process of elimination is kind of a hard way to go find it.
Yeah.
You're looking for the missing hidey hole is what you're looking for. So why did you put the businessman in there? Why did you put the Silicon Valley guy in?
So a couple reasons. He's somebody that obviously is a friend of ours, and he and actually kind of helped pull together a group of people that were helping support the film. He didn't really want to be in it necessarily, but he was sort of asking the provocative kind of question. He was sort of questioning science in a non-scientist way that I thought was really the kind of the point of view of the audience in a way. You know, maybe not exactly, but you know, it's like we all have the kind of the right to ask like what are we doing? What is science doing? Because we're, you know, in the end, we're, you know, this is in service of all of us, and it's in service of all of our kind of quest to answer these big questions. If you go back centuries, we were much more directly in touch with science. I mean, we could see it with our own eyes, and we could touch it with our own hands. And then even, a couple hundred years ago, it's, you can see it through a lens. But now we're really, really removed from science. I mean, we're not seeing it directly. We're seeing it through big data in massive databases with theories that we don't, with mathematics that we really have no way of kind of getting our minds around as a non-scientist. So this gap between kind of our perspective of sort of just ordinary citizens and what scientists are doing, it seems to be much wider than it's ever been. And that's created a lot of challenges, because when we don't understand what science is doing, or we're really not in touch with it, then we sort of, we sort of question it. And right now we're kind of at a time in our society where, or kind of across the board, people are kind of don't understand science and are kind of don't believe it. And I think it's really, in order to communicate about science, it needs to be okay to question it on our own terms with our own language, and then also to realize that our own questions, our own big questions, those are the big questions, and they are valid, and science really is in the service of trying to answer some of those same questions, maybe using a different language. So we needed to find a way to get that perspective in there. But also coming from Silicon Valley, we tend to want things to happen fast. And we tend to, if a paradigm if a paradigm shift hasn't happened this year yet, well, maybe it's only Q1. It's like we expect things to keep having these revolutions, and we've been through several of them. Just in this course of one career, you're through several paradigm shifts. It seems like science. It's been 100 years since there's been a paradigm shift, and it's we tend to be impatient. But that impatience also is maybe something that kind of will drive us forward, because it is possible to get kind of stuck. So I thought both of those perspectives were valuable to find a way to get in there.
So this is really the 6-year-old version question. What do you want to do if you find dark matter? What are you going to do with it?
That's a great question for our tax-paying public. So the answer is perhaps a little bit open-ended and a little bit provocative, but it's kind of intended to be. The answer is we have no idea, right? So we haven't found it. We don't know what it is. If dark matter really is a particle that we can measure somehow, that we can find in the xenon detector or a similar detector, or in a totally different kind of detector, then we really have no idea how it interacts with all the things that we know about, all of the ordinary matter like us. And so the possibilities in some sense are endless. There is also the fact that it makes up roughly 5 times more than all the ordinary matter in the universe. So just on a numbers game, it's very important in that way. If we found the stuff, we know it's all over the place in our galaxy, and the possibilities of usage for a much, much future iteration of humankind thousands of years from now, once we start exploring our galaxy a little bit more broadly, it could be, it could be anything to them.
I get one quick comment on
okay,
that, because I mean, regardless of whether or not there's any practical use for any specific thing that we're looking for, the search for truth does matter. Yeah. You could have said 400 years ago, I mean, Galileo saw the moons of Jupiter, and we're never going to go to the moons of Jupiter. Do the moons of Jupiter really matter? Are we ever going to do anything with the moons of Jupiter? No, but the search for truth and the way we see the world, that's changed everything. It started the whole scientific revolution and the whole way we look at everything. So the search for truth does matter to all of us. And it's probably the biggest thing that matters to all of us, regardless of whether or not there's any practical application of any particular element of it. I think that that's the wrong way to look at science, about whether or not any particular particle is going to be useful in any way. Truth does matter.
Thank you. I'm going to open it up to the audience for some questions, and we have 2 microphones, so it's real important that I'm going to get right back here, and then we'll come down to you, okay?
Thank you. So I just wondered, how are you classifying a paradigm shift? If you don't know that it could, if you don't know that it is one for possibly decades or centuries, like people didn't believe Einstein for the first while after he made his discovery, but then now we call it a paradigm shift. What if what was discovered at LIGO actually is this paradigm shift, changes the way we think about it, we just haven't realized it yet? How do we go forward from, like, how does it become classified as a paradigm shift?
Paradigm shift is a change in I'd say the first principles. So a paradigm shift, like the Earth is the center of the universe versus the Earth is not the center of the universe. That's a first principles kind of change. And Einstein was a paradigm shift all the way back at the beginning. And everybody knew that was a paradigm shift at the beginning. It's really about, are you not questioning the first principles, but you're using it to do other things that may be more incremental? Like, for example, if you're not questioning Einstein, but if you're using Einstein's formulation of gravity to kind of figure out how much dark matter is out there, then you're not questioning the first principles. If you're going back and questioning Einstein, that's a kind of a first principles question. So you do know when they're happening. You don't know if, you do know when you're questioning first principles. You don't know whether or not it's right or not till later, till there might be some confirmation in experiment.
We had a question down here. So who's got the microphone? This is so everybody can hear your question, not just us. So, thank you, Josue.
Hello, thank you. Does the irony of, well, I'll tell you my irony. I used to look up at the sky as a child and as an adult, not too long ago, and think, oh, the stars and the planets, those are the something up there, and there's nothing between all those. As it turns out, what I thought was the nothing is the far bigger something, and the stars and the physical objects there are very minor. So that is a paradigm shift. Is the thing that we thought was nothing is the bigger something. But the other thing is, it's sort of a basic question, maybe a 6th grade question also, is that how have we observed dark matter? How does it change what's around it? How do we see it?
Yeah, so maybe I'll take that one. So there's actually quite a few different independent ways that we've observed dark matter, and we've ascribed all of these different independent observations to the same thing, which loosely falls under this dark matter particle kind of paradigm. So one kind of easier way that we've seen dark matter, which was briefly hinted at a little bit in the movie, is by looking at something called galaxy rotation curves. And the name Vera Rubin was also tossed in the movie, and she was one of the first people to really measure this and notice this phenomena. So if we look at our own Milky Way or any other galaxies, we can see all the stars circling around the center, and we can measure how fast they're going. And ordinary gravity, Einstein's gravity, and also Newtonian gravity tell us how fast they should be going based on how much stuff we see. We see all the suns here, we see all the stars, all the gas, and we measure how fast they're going, and Einstein and Newton tell us how fast they should be going. And what we find is that as we go to the edges of galaxies, the stars are going too fast. They're breaking the rules. They're going too fast. So there's kind of two different ways that you could interpret this. You could either say that there's a paradigm shift that's needed. In other words, something is wrong with Newton's gravity or Einstein's gravity. Or you could say there's actually stuff there that we're not seeing. And so that's one basic way we know about this dark matter stuff. And so interpreting it in kind of the usual Einsteinian way, where you sort of trust Einstein and you just say, okay, then it tells us that there has to be a lot of stuff in these galaxies that are pulling these outermost stars so that they can be stuck to the galaxy and not flying off out to infinity.
Okay. I'm going to go right back here to this gentleman right there. Thank you.
Yes.
Can I have you hold the mic with the tail out? There
With
we
all
go.
of the description of not knowing what dark matter is, who made the decision that it was a particle?
This was one of the questions that we asked. It sort of seems like if you're a particle physicist, every question of physics is somehow answered with a particle.
So, I don't know if I should follow that up by saying it's a particle, but I've certainly written papers where it's a particle. Yeah, I think, so not everyone says it's a particle. There are other kind of easy things that you might guess it could be. So first of all, before we even get into like fancy new particles or anything, one thing you could say is it's normal stuff, right? Maybe it's normal stuff and we don't see it for some reason. Maybe it's not very hot, maybe it's not stars, but it's just normal stuff and we're just not seeing it. And that's probably one of the easiest explanations you could propose. Unfortunately, that one doesn't actually hold up to the data. So there are a few different independent ways we know it's not ordinary stuff. One of them, I encourage you to just Google it. It's really beautiful. You can look up this cluster of galaxies called the Bullet Cluster. It's a very, very pretty image. It basically shows two galaxies colliding with each other, and then we were able to observe the kind of ordinary matter that we could see smashing together. And we could infer, again, from Einstein's gravity and from the sort of bending of light behind these galaxies, that actually there's a lot of matter that passed right through one another in these galaxies. So that's one way that we know that dark matter is not ordinary stuff. So it's not that people really necessarily first thought it was just something brand new, a brand new particle, and maybe it's this one thing. There are a lot of kind of checklists of things that we've tried. Something else that physicists have tried is to explain dark matter with black holes. Black holes we know exist. They're, again, in Einstein's gravity, but it's not a new particle. It's just a black hole, just a stellar kind of object. And again, black holes don't work because we've made various measurements and there are predictions of how many black holes there would need to be, and we just haven't seen nearly enough black holes to account for all of the dark matter. So we've kind of gone down a laundry list of more normal things to think dark matter might be, and we're really left thinking that it has to be either a new particle, if you're a particle physicist, or a collection of new particles, or something more exotic or more paradigm shifting.
Okay. We had a lady in this row. Can we get right to her first? And then we'll come right down to you, sir.
Do you have any thoughts, or do you foresee how this new scientific theory / paradigm shift can unite science and spirituality?
You take that one.
Well, that's actually one of the things that we addressed at several levels in the film, because it's like a lot of the big open questions that are really important to all of us sort of seem to be outside of the domain, completely outside of the domain of science. Like science doesn't really look at them or doesn't have the language for them. And so I used to sort of joke with some of the scientists, trying to get them to open up about some of these other kinds of questions by talking about, most physicists we talk to, if you bring up, one of those topics, life and death or, consciousness or things like that, they look at their watch and say, I gotta go now. They're really afraid to talk about it because it's not really part of what they can measure with their instruments. But what was really, we were really happy with in this film is that as we got to know people, I was saying scientists are people too, but everybody has the same kind of life and death questions and things that are kind of beyond, there's the world of science, and then there's sort of this threshold where the tools of science or the ways that physics is sort of constructed can't really answer them, yet we still have those questions. So there is this sort of threshold where science sort of ends and philosophy and faith and all these other things sort of begin, and scientists don't usually talk about them very much. 200, 300, 400 years ago, scientists talked about them all the time, but in the modern world, it's really hard to get scientists to talk about that. And they're still really tough questions because we don't have the kind of the CERN and LIGO and the giant telescopes and the detectors. You know, they don't measure that kind of stuff.
We had a question right down there.
Scientists think.
What? Oh, you want the scientist to answer this question?
I got somewhere to be.
Shall we leave it at that? Okay, let's come down to this question right here.
So I'm here with a few Napa Valley College students. I see there are other students in the crowd as well. I mean, probably we're all students in a way. But what would you say some of these aspiring scientists and engineers that with so much unknown, what kind of words can you give them to really like inspire them to continue pursuing so many unknowns?
One of the things that just amazed me in talking to these scientists is that there are just really, the mysteries today seem to be bigger than ever. I studied physics in college, and I didn't go into science because it felt like it was too slow, or we had all the answers, or we were sort of doing incremental things that seemed like it would take forever. Looking at it now, it just feels like it's just wide open. And there are just really, really big fundamental questions that seem to be in play today. And we also have some just really breakthroughs in how we're able to observe the universe that are going to yield all kinds of new things that we'd never even thought of before. So it's actually a really interesting time to go into science. Sometimes the first questions that I asked about, most of these people were doing something with gravity. The Nobel laureates, dealing with gravity. I mean, the first question I would ask would be something that seemed like a kind of stupid question, like what is gravity? And the first answer is sort of, maybe the textbook answer, and then my follow-up question was always, yeah, but what is it really? and the answer is we really don't know. I mean, these things are still really wide open. The fact that some of the most basic things that we've known since we were first trying to walk as a baby are still kind of open questions that have to do with the big fundamental nature of the universe. It's an interesting time. It's an interesting time for science.
Do you want to add to that, Robert?
Yeah, sure. So one thing that was kind of featured a little bit in the film, and you've also talked a bit about, is this interesting idea of things happening on human timescales. So I'll just motivate things from that perspective too. So actually, I was just thinking about it. So Einstein wrote down general relativity in 1915, and the first gravitational wave was detected actually 2015. It was exactly 100 years. So that's really nice just for human reasons. It didn't have to work that way, but it was exactly 100 years. It's actually, I hadn't thought about that. But Franz Zwicky first started first started observing some evidence for dark matter in 1933. That was when he first started measuring clusters of galaxies and noticing a kind of similar phenomenon to what's happening on the galaxy scales of things moving too fast and there not being enough stuff there to pull them. And so Franz Zwicky started making these observations in 1933. So I can't do math quickly, but
14 years. We got 14 years.
Yeah, 14 years, xenon, or the next thing should be due to make their big discovery. And 14 years is plenty of time to get into physics and get into the engineering of it and get on that project and then be in the room when they have the champagne.
Yeah. That's a great answer. Did I see a hand up over here? Oh, right here. We have one. There we go, Brian. Thank you.
I was struck, I've thought of this before, but about how scientists have to be willing to fail a lot. And I'm wondering if you have any memories of learning as a child or having an experience that made you feel like you could go into an area of work where it was okay for you to fail over and over again.
Well, I came out of the startup world in Silicon Valley. But actually, they don't like to use the word failure, and they kind of we were at the premiere in Copenhagen with a lot of these scientists on stage, and you know, it's like these aren't failures. There's a long string of learning experiences, and then an occasional breakthrough where some new discovery is made, but it's a constant learning experience. And I think that's the right way to look at it, not just in science, but in life in general.
Yeah, so I'm not sure that I have any one particular kind of childhood memory that drove me into something where I just fail a bunch. But I guess I've always been persistent. And, you know, if I just want to know what dark matter is, and I'm very frustrated that I don't know what dark matter is, then I just keep thinking about it. And it's not so much, oh, this idea failed or that idea failed. And like in my game, it's even worse possibly. I write down a bunch of theory papers, and even if they're beautifully sound and I didn't miss any factors of 2 and all of my math checks out, they could still be totally describing a different universe that's not ours at all. And actually, they're more than likely doing that. So I'm really throwing a lot of darts and just totally not even playing the chess game that I'm supposed to be doing. But I don't know. I guess I'm really just driven by not knowing answers to the things that I'm bothered by. So dark matter is one of those. It's so much stuff in the universe, we still don't know what it is. And I'm very frustrated about that, so I think about it a lot.
Physicists are the kids who just never stopped asking why. And now they're just, you know, they're grown up using bigger toys now, but they're still just asking, they just still keep asking why.
Did we have a, well, I'm going to, I'll get there, and then we'll come back, we'll come down here. Go ahead over there, that'll be easier. And then Josue, if you want to come down here to the front.
I have a question about CERN and just the physical makeup of that amazing facility. And if you could describe a little bit about what goes on there and what those machines are. And boxes, are they calculating things? Are they running experiments?
So what it's actually doing when they're running it, they're colliding, they're just smashing particles together. Kind of like when you're a kid and you like smash rocks together to see what's inside. You just imagine keep smashing smaller, but they're colliding, I don't know what it is, many tens of millions of particles a second and collecting data. So this thing runs for, runs for a long period of time, and they collect all this data. Just like the underground detector is the same thing. It's like they turn it on, they're collecting all this data, and then they predict what they're going to see in the data, and then they look at the data. So it's those server rooms full of all the computers. Those are at CERN, because they're sitting there just collecting masses and masses and masses of data. And in that big haystack, they're looking for particular needles that are predicted by their theory.
So you talking about data actually got me thinking about one fun fact about CERN. So some people might know this, but the internet was actually invented for CERN. CERN is the result of all the cat videos that you watch, or caused all the cat videos that you watch. And originally the problem at CERN was we have this massive amounts of data that we're collecting all the time continuously, and we need to distribute it to the 6,000 scientists that work on this data and work on this experiment. And so the internet was invented. I only mention that because that was a totally tangential, unpredicted, society-wide, huge paradigm shifting, all sorts of benefit that happened in the 1990s. And it's just because we lived in different places and we had a bunch of data and we were very petulant about it and we needed it right now. So the internet was invented. So yeah, that was just a fun fact.
That's a fun fact. Can we get the right here, please? Thank you.
Thank you so much.
Can you hold it up?
You got wonderful.
Yeah. There you go. It's like a comet. The tail has to go out.
Thank you so much for a wonderful movie. And for including so many women scientists also. And I want to know where we can see your movie again. Is it on a streaming service or?
So in the next few months, it's traveling around to different festivals, and then hopefully it's going to come to some theaters over the summer. And then by, we'd like to release it more widely out for home is the 100th anniversary of the publication of the Arthur Eddington's paper that was the one that made Einstein famous, which was November 6, 2019. That's the 100th anniversary of that. So we've got to have a 100th anniversary of something.
It seems like this would be a good educational movie too, because we've had Particle Fever, we've had some of those other films, and so when you're talking festivals, where else are you going in for festivals?
Well, we decided to say yes to anybody who asked it to come to a festival, but there's a few coming up. It's playing at the Cleveland Film Festival next, and then it's actually playing at a science fiction film festival in London. It's playing but it's going to play at the CERN Film Festival. So in that dome at CERN that you see, that's going to in Geneva. So that'll be interesting.
That'll be very cool. Well, I really want to thank everybody for coming out tonight, for believing in our Science on Screen program, for Steve to come and fly here to be a friend of the Cameo and let us have one of the first peeks. And also, thank you. And for Robert McGehee to come up, I know that he's got theories in his head now, and this has opened up maybe some questions in that for him, but to work with us in Wonderfest to make it really interesting. As we were saying earlier today, we do have several students in the audience, and they may be the ones that discovered this particle. So I do want to thank everybody for coming, and especially our two special guests tonight.